why and the content, etc., and where we move from here, as a prelude to some of the wonderful speakers we have lined up today, who are going to talk about some of the actual deployments and their experiences in deploying some of the technologies we're going to talk about. So maybe I can set the next slide, please, Eurelectric. So let's start with why the report. Why are we actually have we published the report? Why have we spent the time and energy putting it together? Well, we've heard virtually every actor, every stakeholder in the industry, in and related around the development of the distribution level, saying innovation is key. It's absolute necessity in order for us to hit the targets and to make the change that we're seeing, and to move that from what is effectively a series of innovative technologies and maybe a number of pilots to mainstream is a big challenge. So we wanted to look at this and say, well, how could we deploy innovation at scale on the distribution system quickly? And we realized that the DSO is probably, well, not probably, will be bearing the burden of the energy transition. There's a number of figures out there, but generally somewhere in the region of 400 billion euros of investment is predicted. And if we look at that portfolio of development that would need to be undertaken across the distribution grid, and we were to look at what could be done with the types of technologies that we would represent, the innovative grid technologies, just a 10% efficiency and an improvement of that portfolio of projects would reward 16 billion in savings to the industry. So there's a huge potential there. And new technology is obviously very rewarding, but it's also extremely challenging. We also recognize that the development of innovation is very, very different when you look at it from a DSO perspective to the cousins in transmission. There's much more resource constraints in regards to onboarding new technologies. The DSO DSO industry tends to rely much more on standards and specifications. There's less ability to be very bespoke. And even though standards bodies were not predicting, like many of us couldn't, the scale of things that would need to be done on the grid, and they're feeling very paced. And justifying innovation is extremely hard, particularly given the level of uncertainty. It's growing, it's becoming more difficult to see what's going to happen in 5 or 10 years into the future. And finally, but probably very pivotally, the DSOs and their networks are changing quite radically as well. There's a lot more people connected to the grids. There's a lot more generation of demand side response. There's a lot of interplay there. So that's why the report. Maybe we can go to the next slide, please. So what's in it? Well, the first thing we should probably say is that it's a living report. We don't expect to do this once and walk away. We expect that we're going to come back and do regular updates. And we've even planned for later this year maybe to go back and revisit, look at adding new technologies. And part of today is to talk to you and find out what you would like to see us do in that report and to help us shape that as we move forward. But we may do updates and additions as we go along throughout the year. We've broken the contents down into a number of key areas. So first of all, what do we know from our own experiences, from the experiences we dealt with the customers and collaborated with in regards to the issues that need to be overcome? There's some general things that happen whatever the innovation, whatever the technology you're trying to bring through our experience, and there's some general sort of ideas and recommendations that come out of that, and then some that are more technologically specific. And we have some concluding recommendations, and you see on the right there the 5 key technologies that are being presented in the report today. As I said, we already have plans for more to be added in, and we welcome your thoughts on that as well. Maybe we can have the next slide, please. So just a very high level, just to make sure everyone's on the same page, we'll just break into those technologies just a little bit and just give a very quick overview of what they are. So the first up would be modular power flow control. These are devices that are connected onto the power network to control power, including the title, and the way that it flows through the network. And they have a proven track record. They can add gigawatts of additional power when you look at a network and the capacity it can release. and that could be translated into hundreds of millions of euros in savings and congestion, avoidance of design. And they're modular, so they don't they grow and scale in size over the course of time. It can be moved and resized quite easily. The second would be dynamic line rating. It's a system that's installed to look at the environmental impact of what's actually happening out in the environmental sphere around the lines, to see how that would impact on the ratings. As many people know, a lot of the ratings are static today, and we're moving to that dynamic world. The reason they're static is that we need more information on what's actually happening out there. But they can offer a 200% daily or 30% annual increase in capacity. Advanced conductors, looking at new conductors that can go up, replacing the existing conductors that are there. They can offer an increase of 200% on the transmission capacity as well. And they do that with lower losses and reduced sag. So you can see there's big benefits and different characteristics to each of these technologies. Sensors, we've also talked about a range of sensors, given better accuracy, reliability. 80% less resources are required in equipment and materials, 70% less power, 30% lower cost. And then finally, digital twin, really a way of sort of, I suppose, making the best of all of those technologies by looking at the real world physical power network, digitizing that, having the ability to be able to study, understand, simulate, integrate, operate, etc. With that behind. So maybe we can go to the next slide. I'm not going to walk through all of the recommendations in the general area, but in the general, what we've actually tried to do is looked at some of those issues that are universal. We've tried to look at those that span the whole of project development. So it's from conception, the start, I need to analyze, I need to understand what's going on with an issue, to consider a technology, all the way through to commissioning. So there's a number of different recommendations that span that entire development cycle. We try to provide guidance on how you might manage some of those key issues. And there's a commitment from all of the OEMs within Current, not just the people who are involved in the paper, to support you and any other developers of those technologies going forward. Have the next slide, please. And if I then look at specific deployment recommendations, what we've tried to do to make it easier for the reader to get involved and to compare and understand and contrast the issues is to try and keep the same kind of areas on the right-hand side. Yet again, I'm not going to walk through those, but what we've tried to do is cover all of the tech assure and deployment issues that we've seen in the past, the areas that have been problematic or interesting, should we say, from a technological point of view, with past distribution system operators when we've developed the projects. Yet again, we tried to cover all stages from conception through to commissioning. We've looked at key concerns in the suitability of the technology, how does it perform, the cost, and how do you select between them, or select between it and conventional technology. So it's trying to cover all of those areas in the round. We've provided example cases where we've got a lot of experience and learning from that, and that is to provide learning and outreach to other people who'd be interested in the technology to see the look and feel of how it worked and what was the achievement at the end. And then finally, we're trying to give best practice to the industry as a whole for each of these technologies. Maybe the last slide, and I'm going to hand over then to some of those people who've provided some of the examples and some of the technologies for people to explain. But we had a series of concluding recommendations at the end. Some of those have already been much more far developed, progressed even since we wrote the report. We said, look, energy efficiency first has to be the case. We want to benefit from grid optimizing technologies. They're much faster, cheaper, more flexible to deliver than a lot of conventional solutions. They are part of the portfolio. We don't think the conventional solutions will not continue, but it should enter and be used actively and at scale. We talked about a distribution technopedia, and there's been a lot of movement on that, which is great to see. For distribution, and we'd like to help people in making that develop, but we see it should identify best practice range of technologies to be considered by all actors within the distribution system operated space across Europe. Technical assurance. What we're really saying here is, look, we understand technical assurance needs to take place, but please try and focus on those things that are actually required for functional needs. You know, there's a risk of going much wider than is necessary, but obviously you need to investigate and ensure that you're going to get the performance you're looking for from the technology, but be focused on that. Application of symbiotic technology is a really interesting one from my point of view anyway, which is the fact that, you know, the report talks about considering these in combination. We've done some preliminary work ourselves. We can see that a number of the technologies we've already talked about, when you use them together, they have a multiplying effect. It's not just additional. You don't just get A plus B, you actually get something extra. And by combining them all together, you can do something quite powerful. So each has a certain capability of the network, but in combination, they provide much, much more. So innovation incentives, we understand that it's a real challenge, as I say, to move to new technologies. And we've asked for recommendations to regulatory bodies and policymakers to introduce incentives in this area. And as I say, some of that is, you know, a hot topic at the moment in the industry. And trialing what's mattered is one of the biggest and most key recommendations to come from the report. You know, there is this death by pilot. A lot of people are keen to try technology, and it becomes very difficult then to translate that to scale. And we want to, we recommend, and we'd like to see, you know, how we can help in making that movement from first pilots to widespread deployment, and applying a way of streamlining of trialing and rapid spread of technologies is absolutely key to hitting the targets that we're looking for. And knowledge sharing is one of those, and hopefully we're going to do a little bit of that today. So I'm going to stop talking. My time is up. I will hand over to other people who've been working on some of these DSO projects to walk you through and talk you through their experiences and some of the challenges they've made, and hopefully to provide you some interest on how you might go about doing it yourselves. Okay, Leila, will we hand over to Pat?
Hi, thanks to Mark. Mark is, of course, the chair of Currents Incentives Regulation, our DSO working group, and he is the VP for Business Development for Smart Wires as well. So many thanks for the presentation on this. If we are able to hear Ricardo, I would first like to give the floor to Ricardo to say a few words, and then we will have Pat. Ricardo is team leader at DG ENER, was very involved in the grid action plan, and also is doing a lot of work on DSO. So I'd like to give the floor to Ricardo, please.
Yes, good morning. Just to confirm, you hear me now?
Yes, we hear you. We hear you.
Very good. Thanks. And I will be brief. I don't want to interrupt the flow of going into the concrete examples of what is needed. Just to give a little bit of perspective on what we see on the Commission side. I mean, first of all, it's obvious that that we need to go into more focus on distribution in Europe at large. Of course, that is traditionally a very local perspective. But growingly, it has a more direct interlink to achieving the European Union's objectives at large. So with that in mind, we did together with the public adoption of the PCI Project of Common Interest list of important projects for cross-border energy infrastructure in Europe, which took place on the 28th of November, and we did it in the annual PCI days. We adopted another communication complementing it, which is the Grid Action Plan. And the Grid Action Plan gives a bit of context on many of the things that I'm very pleased to see in the previous slides and in the report. And the first one is the importance of distribution, of course, as I was saying, where in Europe, or in Brussels at least, we as I was saying, it goes more in the national perspective or even municipal. So normally we don't put the political attention so high as we did in November, where we highlighted, first of all, the investment needs going into the largest percentage of infrastructure investments that are needed in Europe in the next few years to meet already the 2030 ambitions. So we first of all put the political attention back there where it should be now, but also we named a couple of actions that we believe are needed to deploy the distribution grids that we need. And the first thing to raise is, of course, that we need both capacity, so new wires, new cables, new transformers, but also new smart grid technologies that help us operationalize better the networks. And those both sides of the needs should be reflected in the different parts of policy and regulation, starting first of all with network development planning, with DSOs considering all the technologies that are needed when doing the needs assessments, the network development plans for the grids. We also think there needs to be, in certain jurisdictions at least, a more focus on the regulatory side, on how to incentivize from a remuneration perspective that those technologies, both more traditional and more innovative, are there. And there a reflection of tariff structures on considerations on CapEx and OpEx, operational expenditures. Those elements are also important to incentivize a more efficient usage of the network, and that goes also by deploying the technologies that help doing so. So tariffs and the role of national regulatory authorities is very important. So is sometimes to look into funding opportunities or options. Also because tariffs are can be an important part of the bill of the consumer, and we also always need to keep the affordability angle in mind for the final consumer. And here in what we are doing now in DGN, as also we committed in the Grid Action Plan, is to do a mapping and understanding of what are the usage of the different funds at European level on distribution, and also including, of course, on smart grids and innovative technologies. And also a reflection on another angle that I saw in the previous slides on supply chain. Also that we raised it, and it has different components, in fact, from the availability of materials, copper or aluminum for the most traditional technologies. But beyond that, what we raised is that there is probably a requirement to streamline to an extent procurement. And it goes, our last of the two actions of the Grid Action Plan go similarly in the direction of dysfunctional procurement tender specifications, and how to streamline and ease a little bit, both from the client, from the DSO, and from the supplier point of view, that procurements are as streamlined as possible, and easing also the human resources needs for such exercises. So very high level and very quick, but just to give a bit of the context of how we see the things that are being mentioned, and we are quite pleased with what was presented in very high level before. Because it goes very much into operationalizing and helping us go a little bit further in the discussion on what we need and what we think we need in accordance with the Grid Action Plan. So that's all from my side, and I wish you a good workshop. Thank you.
Thank you very much. I think that Ricardo cannot stay until the end, so if there are any urgent questions to Ricardo on the chat, and otherwise we will certainly be sharing the outcome from today's workshop with Ricardo. So many thanks for joining today. Now moving on to the DSO side. So our first speaker from the DSO side is Pat Howe. He has over 40 years of experience in the electricity industry, and pioneered the use of advanced conductors with SSE, where he was formerly a project manager, and he will be presenting today a use case on deploying advanced conductors if we have managed to solve the technical difficulty, and we can in fact hear him. Pat?
Good morning. Good morning.
Very good. Excellent.
Yes,
nice to hear you.
Doing a presentation on technology and being defeated by your own laptop. The irony isn't lost on me, so apologies, and good morning, everyone. So yes, a bit about Scottish and Southern first off. They operate the distribution networks in the north of Scotland, and there's a transmission network there as well. and also the distribution network in the central southern England as well. It's around about a quarter of the UK landmass. Next slide, please. So the project we're going to talk about is a 132 line between Fort Augustus and Fort William. That gives you some idea where it is on the map, and it goes through what was Glen. The 132 is a distribution voltage in England and Wales, but is actually a transmission voltage in Scotland, but it's a common voltage. Bit about the line: 44 kilometres in length. The existing conductor was links ACSR. The existing earth wire at the top, it's a lattice tower line. You'll see a picture in a minute. Was horse, and it's a double circuit. That dates back to 1955, as we were saying on there. Next slide, please. So this gives you a rough layout. Whoops, can we go back one? Would you mind? Sorry. That's great, perfect. So very good. Okay, so this gives you an idea. It's a radial circuit. So it's supplied from Fort Augustus down to Fort William. We've got two tee-offs, one going away to a place called Quick and the other one to a generating station in Vegdani. So the thing is, the challenge, as we're going to get to in a second, was not only to increase the capacity of the line, because the smelter, which was a major customer at the far end, was looking to expand, and also to safeguard the jobs for a new investor. But also because it's radial without a backfeed, we had to reconduct to the line with one circuit live, and also be able to put the supplies back on in the event of emergency, because otherwise the aluminium would go off in the machines in the smelter, and that would be the end of the smelter. So quite a few challenges, as you can imagine. On to the next slide, please. So this is the sort of terrain that we were dealing with, very challenging. Needless to say, building another line was completely impractical, because if you look at it, the route, obviously when the original line was built, they picked the best route, and what we've got left would be pretty much insurmountable. Plus we were under a lot of pressure from Scottish Government to support the new investor for the smelter. So in typical fashion, and you'll be unsurprised listening to this, everyone wanted the thing done yesterday. So we needed to come up with an innovation in how we were going to do this. We also had some existing issues with clearance on the line as well, which we were looking to try and get fixed at the same time. And we wanted to try and keep the existing assets as we could, because of, well, from a practical point of view, in trying to rebuild towers online, we putting interrupter cables in, etc. So we were really looking to try and be it wasn't sustainable at the time. It was a practical thing that was driving sustainability, but as you'll see, it really worked well for us. Next slide, please. So on the left is our original links conductor, but as you can imagine, as it had been up in the air for quite some time, it looked nothing like that. And on the right is the Monte Carlo ACCC that we went for. This is a carbon cord conductor with a very highly conductive aluminium wrap on the outside. And what we did was we looked at all the high temperature, low sag conductors, and we went through a sort of testing process, which if you go on to the next slide, you'll be able to see. So this is the sort of requirements that we had. We went through it. We looked at a traditional conductor, which was UPAS, but as you can see, it didn't meet the capacity requirements that we wanted. It also wasn't fixing our clearance issues either. We then looked at Monte Carlo. Monte Carlo is just a size of ACCC conductor, okay? And then we also looked at other HTLS conductors as well. And we did sort of cost benefit analysis. We looked at the weight, everything else there, the support and whatnot. And we went for the Monte Carlo. We ticked all the boxes as far as we were concerned. What I'd like to bring your attention to is the picture on the right. Now, I haven't faked this because I'm not technical enough to be able to do it, even if I wanted to. On the left is the new Monte Carlo conductor, and on the right is the old links conductor. Now, I know it looks like the one on the right was pulled up by hand because it sags so badly, but genuinely that is the difference in profile between the two conductors, and it gives you some idea of the benefits. Now, bear in mind that we've also, with the one on the left, we've doubled the capacity of the line on the existing towers. by just restringing. So if we go on to our next slide, please. So this gives you some idea of the sag profile of the existing links conductor. The green line at the very top is an earth wire for lightning shielding and obviously earthing the structures. One of the things, as you'll see when we go on to the next slide, is that the new low sag conductor is so good that the earth wire actually would have been dropped below the top conductor. Such is the benefit in increased clearance, ground clearance. So if you do have an earth wire, you'll probably need to change that at the same time. We took the opportunity to change it for one containing the fibre, so we were getting a better comms and better protection and control out of this as well. So if you pop the next slide on, please. Oops, we seem to have lost the second one. Can you go back one? Sorry. Okay, I do apologise. Right, we seem to have lost a slide, but basically what would have happened is you would have seen that there would have been another conductor on overseeing that, and what you would have seen is that the conductor, the low profile sag, would have actually been across where that red line starts, just below the green line. That would have gone almost vertically across, and it's not because it's pulled up to a massive tension, it's just because of the structure and the way that the actual thing works. Okay, so on to the next one, please. Okay, so progress on how the project's gone today. Effectively, what we've done is we've got, it's been in operation since 2018 and 19. We've not had any issues with it whatsoever. We only needed to change 3% of the towers over the route. We had 155 towers. We only needed to change 5 to accommodate both the new conductor and the additional clearance. We had a canal to go over, so we needed the additional clearance for masts for boats, for example. So it's, you know, it's worked out really, really well. The particular tower we were using it on, it was a PL16, which is very common throughout the UK, and also I believe has been used in other parts of the world as well, because it's quite common. We really scrupulously went through type testing to all the standards. We took the conductor to independent labs throughout Europe, so that we really chucked the kitchen sink at it to make sure that it did everything that we wanted it to, and our engineers were independent from the project, so we were absolutely confident that it's passed it. So we now have Monte Carlo as an approved product as far as we're concerned. We've shared the information with the wider industry as well, so that other people can use it, and it's now on our sort of standard product list of when we want to for doing other projects that are similar, and we've reused Monte Carlo on other circuits since. So basically what we've done is we've used virtually all our existing assets, but we've doubled the line capacity, and the customers were pretty much unaware of any interruption. There was no interruption to supply, fortunately, over the 2 years that the project went ahead. And as I say, the smelter was able to carry on with its project and increase its capacity. If you wouldn't mind popping the last slide on, please. Great stuff. So I've mentioned Monte Carlo in this. Monte Carlo is just one conductor, one size from one company. There are many, many other types out there of manufacturers. The important thing is to engage with the manufacturers and speak to them, and then work out what size and type suits your individual needs, okay, and for your particular structures. The reason I brought this one to you is we've all got this 2030 date hanging over us. We're trying to get as many customers connected as possible. You know, the number of connections are huge, and the pressure on us to get all this stuff done is also the same, right? So this offers a chance to keep our existing line structures in place. As you know, when you normally go to a bigger conductor, you need to shorten span lengths, looking at extra structures. That's not the case if you go for this type of conductor. So that's the really, I wanted to bring it to your attention. And the last bit really is about sustainability. You know, everyone likes to talk about sustainability, but genuinely, we've managed to double the capacity of a line by changing 3% of the structures. I think that's a really sustainable thing. And that's me. So any questions later on, I'll be more than happy to answer them.
Pat, maybe just since we have 1 minute left, maybe what would you, now you mentioned you did extensive type testing, etc. What would you think that others could do faster now that you've already gone through this experience? Do you think that others can save time because of the testing that you've done?
I think part of it as well is that it's giving other people in the industry confidence if they can actually come out and physically see the line. I think it gives people confidence that a company's actually spent the money, put it into service, and is actually sort of proving that the technology works. I think that's the sort of best advert you can have for a type of technology. I think it's very easy to do it on a sort of small scale, but we're now, as I say, we're now putting this ACCC conductors in as standard on lines, and it's really making a big difference. You know, it's allowing us to connect customers much earlier, and I think it's a thing that distribution will embrace, no question. I just think it needs someone to have the confidence to try it. But when they see there isn't an issue with it and they get the gains that they potentially can get, I think it will become much more widespread.
Okay, thanks very much, Pat. And I hear that as an open invitation to anyone who wants to come look at the line themselves. Just a joke.
No, that's good. Yeah.
Very good, very good. Okay, thank you very much, Pat. If there's any questions in the chat, of course, feel free to address them to Pat, and other questions later in the Q&A. In the meantime, I have the pleasure to address our next speaker, which is Andrew Burton, who is Innovation Project Lead at UKPN. And Andrew will be presenting a use case on advanced modular power flow. So the floor is yours, Andrew.
Thank you, Leila. Good morning, everybody. So, yeah, as Leila said, I'll be presenting use case on the project load share. Next slide, please. So, first we looked at what the challenge was really. The challenge that we had was that we had one circuit that was consistently going high, and it was causing problems on the network. And when we investigated this, we identified that there were 3 circuits, all different lengths, and they weren't balanced properly. So circuit 2 was the shortest length, therefore the impedance was lower compared to the other 2. So also we sort of had consistently changing load. So on each of the feeders there were different sort of distributed generation types on there, so the load was constantly changing. But upon investigation, we identified that the power flows were sort of high through circuit 2, but there was spare capacity on circuits 1 and circuits 3. So we investigated sort of what we needed to do on here, and any reinforcement was a complex problem. There was the overhead line route was going through a site of scientific specific interest, which meant there was lots more hoops and requirements that we had to go through. So we had to think outside the box and come up with an active solution that could solve the challenge that we were posed with. So next slide, please. Yeah. So the solution, what do we look? We looked at a number of solutions. So as I said, reconductoring, replacing the overhead lines was an expensive solution. So we looked at various options. One of those options was the modular power flow devices. So we investigated the devices from SmartWires. So they had 2 devices called Power Guardians that sit on the overhead lines, and the Power Line Guardians. The Power Line Guardians sit in the substation just after the bus bar in a primary substation. So we initially looked at deploying all the Power Guardians on the overhead lines, so the compact deployment. But the problem with that, because it was the environmental impacts that could have been through the sites of special scientific interest caused problems. So Then we looked at deploying all power line guardians, but the challenge with that was that we had to install quite a number in the substation, and we didn't have the space capacity to allow that. So we looked at then combining the power guardians and the power line guardians. So the power line guardians are have lower capacity ability, whereas the power guardians are 10 times more than the power line guardians. The way that these work is that they're wrapped around the conductors, and then they sort of induce impedance on the line that then you can control power flow, but it's more dynamically. So you're able to dynamically control the impedance across that line up to the total of the number of deployments that you've got in there. So what we then started to look at is the deployment of these and where they need to be deployed. So we can deploy them across the two circuits, so on circuit 1 and circuit 2. So then as the impedance changes, we're able to constantly update that impedance and dynamically change that impedance with the deployment of the power line guardians. The ability of this was that we're able to monitor the circuits, we're able to monitor the temperature, and we're able to sort of push the power on the spare capacity across the other two lines. This can unlock more spare capacity for more generation to be connected. Next slide, please. So with the deployment, so when we started looking at deploying these, there were a number of aspects that we needed to look at. So before we even got to deployment, we needed to look at the technical assurance. So what did that include? So that included an initial assessment. So I think, as Mark touched on earlier, that there is compliance that we need to follow. There's certain standards that we have within UK Power Networks, but across the wider sort of industry. So we had to assess those against our technical specifications. We had to ensure that all the type tests were undertaken, that the fault ratings of these devices were compliant. So we looked at those and ensured that that was safe for deployment on the network. But then there's also the operational assessment as well. What's the impact on the network when we start to use these? So we had to do some modeling, understand the impact on the network. But then it's also the associated infrastructure. How much do these devices weigh? Can the existing infrastructure cope with the additional assets that we're installing on there? So we had to understand that and sort of the weight of these devices, what the impact was, the interactions with the infrastructure. So then that's when we sort of, alongside that stage, is that we started to looking at our design and planning stage. So we had to do the tower and foundation assessment. So again, with the impact on the associated infrastructure, the weight, we needed to understand the impact on the connections to the tower, but also the sag on the overhead line. So we had to do a LiDAR assessment, but what we also had to do is we increased the operation of the line to 70 degrees, which also impacts the overhead line. So we had to do that LiDAR investigation to understand the swing and the sag and what the constraints were on site, whether there were any anything that's going to interfere with the overhang as well. And then we had to look at developing a communication system with the devices on site. So we had to involve our cybersecurity team. So it's another aspect that we need to consider. How do we then get the units to communicate back to our control center? So we looked at utilizing mobile phone network, but also we used a private network within the communication to the power line guardian. So using an ISM band that we communicated with the devices, but then we looked at how we then communicate back to our asset management systems as well. So we connected it into a UK Power Network server. So it was all integrated internally within our network. So it was all ring fenced. So there was no interaction with the outside, apart from the mobile phone network, but then that came straight into the SmartWires power line gateway, and then from there it went into the UK Power Networks network. So we considered all the cybersecurity aspects on there. But then there's also the system integration. So we had to then understand what our network control wanted to see, what interactions they want to have with these devices, what alarms, how do they get notified in the event that something's happening on the network. So all of that system integration needed to be undertaken. And then once we'd sort of identified all that, we'd then also sort of start to assess what we need to do for deployment. So we needed to access the towers. All these towers are in various landholders' estates. So we had to then get way leaves. We had to understand who owns the land, then getting access and getting way leaves approved for accessing the towers. And then there was the line outages as well. So once we've sort of identified the solution where we're going to install these, we needed then to start planning the line outages. So the line outages had to be planned significantly far in advance because of the network that we were connecting to. So I forgot to mention at the beginning, it's a 132 kV network. So the impact of outages could be significant. So we had to make sure that was planned. But also we connected into the grid supply point. So any outages with national grid, we had to consider those as well. And that was one of the challenges that we encountered, is that there was an emergency on national grid. So our planned outages had to be rescheduled. So that sort of delayed us as well. So it's those considerations when you start looking at deployment, or at least thinking about design and planning, is the line outages as well. And then we move on to,
sorry, Andrew, just to say we have about 1 or 2 minutes left. So, and we still have some slides. So just a heads up on the timing. Thank you.
Yep, sure. Okay. So then, yeah, almost there. So deployment, again, it's that installation considerations, then the commissioning side. So we needed to sort of cover our requirements with the commissioning to ensure that it's performing. So on the side there, it sort of shows that how the devices operated, and then we had to go into the significant trials. So we had to sort of trial it over a long period because we had to assess the performance of the device. Move on to the next slide, please, Ewan. So the operation. So as I mentioned, that sort of the system interaction with our network control. What we did is we had to. It was more of a light touch from our network control, is that they just wanted the system to operate automatically. So we introduced an automatic balancing algorithm that looked at the injection of when the injection occurs. So this is just a demonstration of when it will incur. So the power line guardians will kick in at 180 amps, and the power guardians start to inject at 300 amps. So it was just an algorithm just to sort of say, if you see this, then start to activate the devices. Therefore, our network control didn't really have to do too much, just monitor the performance of the device. Move on to the next slide, please. So the benefits of deploying these devices is we saw that we were able to release 95 megawatts of capacity, which is equivalent to 45,000 homes. It will also enable new connections on constraints part of the network. It's a faster solution, so you don't have to go through the reinforcement side of things, but also it gives you the ability to dynamically control your network. And as I said, sort of avoid the traditional reinforcement costs and disruption to landowners, road users, etc. And also we saw that the saving was quite significant. So with this just this small deployment, it was sort of 8 million in savings to our customers. Next slide. And that was it. Thank you.
Thanks, a big thanks to Andrew. I see there is already some questions popping up in the chat, so feel free to answer those, or otherwise we take some of them at the end. Now I have the pleasure to introduce Moonis Vegdani, calling from literally all the way across the world in New Zealand, who is Chief Strategy and Transformation Officer at Counties Energy, and he will be presenting work they have done around active energy orchestration. Moonis, the floor is yours.
Thank you, Leila. Good morning, everyone, and it's good evening here, but nonetheless. Thank you very much for the opportunity to share some of our journeys on the DSO capability development front, and happy to take them through at a very high level. Next slide. The slide pretty much gives you a high level of how we look at the strategic need to look beyond the status quo. Counties Energy, its location is in the largest city in New Zealand, that's Auckland, and the way the city is growing, it's growing south at a pretty rapid pace, and that's all of that growth that's coming through in our catchment. Typically, you would see an illustrative load curve over there. Every time you see a load growth, you would kind of bang in peak capacity one step at a time as it's needed, and typically these are 40-year assets. What we're seeing is demand on the network. We're expecting the demand on the South Auckland network to grow because of the growth in the region. There's also going to be, given the regulatory and the political forces at play, there is a rapid growth due to decarbonisation in the area as well, and also new loads like electric vehicles, which we're seeing coming on quite at pace in New Zealand. So the bit of a mind shift that we're looking at the moment is, how do we really look to bring stretch and flex into our network using smart network orchestration, like dynamic voltage control, like using low voltage visibility, and also bringing spare capacity or utilizing the spare capacity that is always there on the network with and using the DERs as flexible assets and commercial arrangements. A key part of our strategy and our work is all about customer. Everything that we design from strategy down is keeping the end customer experience in mind, even as engineers. And then subsequently, what do we need to do backwards from a commercial perspective, and then subsequently engineering perspective to make that customer experience make happen, right? And to that effect, the concept of dynamic operating envelopes, which is quite popular in this part of the world, and the exploration of flexibility tariffs, which we can talk about. Next slide. So kind of wanted to start the discussion actually not with engineering principles, but more about guiding principles that we use to help us embark on our DSO transition. We've got 8 of them, and I'll probably just speak to the first one because I think it's quite useful. The first and foremost and the most important one that we follow is start small, scale fast, and be the right size. We do not want to go and build a DSO that is 20, 40, 60 million worth. When the need and the opportunity is not there. That just brings more cost to the business and subsequently more cost to the end consumer, which is something that we don't want. So timing is actually really, really important, and that is something that we put a lot of focus on. That's what the board puts a lot of focus on as well. All the other ones, including kind of being a neutral capacity service. Our market dynamics are a little bit different. Our market structure is a little bit different. It's a lot more, it's less vertically integrated. So we actually have to work with the ecosystem to ensure that we're offering a neutral capacity service. There's the element of creating and delivering shared value to our customers. So it's at the end of the day, if it's not making sense to our customers, it's no point talking about DSO. Next slide. Talking about, I guess, the high-level transition program, we see this as a multi-year transition program. We actually started off our journey in 2022, where we started with developing the strategy, the stakeholder discussions. Our stakeholder discussions were far and wide, not just within the organization and perhaps the board and the shareholders, but all the way to the regulatory bodies like Electricity Authority in New Zealand. We wanted to socialize our direction nice and early, get the regulators on board and get them supporting. Then we started with phase 2, which is where we're at the moment, and we split phase 2 into 2 milestones. The first milestone was to actually demonstrate on paper, on a desktop, the commercial benefit of running a DSO in the New Zealand market, given the market structures. And then subsequently, so we finished that piece of work. We happily submitted an 80-page document to the board, which I'm sure they've enjoyed reading, perhaps demonstrating all the way from commercial benefit, but the end customer experience, etc., that we're looking to translate. And now we're in a in-field, well, we're working towards an in-field pilot of the end-to-end demonstration of the DSO capability. The idea, again, is start small, scale fast, and be the right size. This gets us to the first milestone, which is offer a base DSO service into the market to our consumers next year or by the end of this year, and then iteratively look to grow the DSO services. And we're working towards a catalog of DSO services that the organization would offer. Again, all of this needs to flow through the regulatory framework, the regulatory discussions, and then also the commercial discussions as well. At the end of the day, we do need to test and ensure that whatever we make is actually tangible and is of value to our customers, and they are actually going to use it. So a lot of customer research and testing and trialing is part of this process as well. Next slide. Just, I guess, drilling on the current phase that we're in, which is phase 2, milestone 2. Again, that's for the in-field pilot of our end-to-end journey, end-to-end DSO service. So this particular milestone has its key objectives, and they're on the slide here. You know, we would like to map the electrical model end-to-end from an LV network perspective. We've got the HV, we've got the MV. We're really focusing on the LV network, where we're quite lucky in the sense where we have 97% smart meter penetration, and that smart meter penetration is that's all the data that we get back. However, a lot of that is still at a consumption data level, and we would like to go to the next level to an operational data set. That's, you know, your voltage, your 4-quadrant data of data set from a meter. The historical smart meters, smart meter data, and running power flows using them to do granular LV forecasting and constraints modeling, model different EV charger penetrations. Again, we're looking at long term and trying to see, okay, great, if these are the forecasting, these are the modeling constraints, what are the different penetration models that we need to run to in relation to the usage profiles to create the LV constraint models. Live monitoring of the grid states and detect forecasting congestion. Again, that is end-to-end from consumer, the DER or the consumer energy resource, all the way to the network and upwards, creating dynamic operating envelopes to address these LV constraints. And our model is to communicate the dynamic operating envelopes to the DER aggregator, who has a relationship with the end consumer. We are also looking to bring 2030.5, this IEEE 2030.5 for communications or communicating the DOEs to the respective DER aggregators. This involves building the client side as well as the server side, and initially using OpenLoop, which is an EV charging service that we offer as a standalone service as part of our organization. So we do have a DER aggregator that we can trial this with, and then again post-event reporting when it comes to how did the DER's response to alleviate the LV constraints that we were expecting. Next slide. This brings us to our technology partner, FlexiGrid. This project or this milestone was kindly funded by an organization called Arake in New Zealand. It's a governmental organization that promotes future energy development and people that are working on the cutting edge when it comes to network management technologies in New Zealand. And we're looking to utilize the 3 components of FlexiGrid's platform here, which is grid planning, monitoring, and flexibility management. That's ARI, Tatari, and TIA components of their platform. The next slide gives you a slightly, just going on to the next slide, will give you a high-level view of the architecture that we're implementing. On the right-hand side is the DNO, and this is the happily running network, which provides the safe and reliable service. The next box over there, which is a DSO box, that's the box that we're actually building as part of the flexibility or the energy orchestration intelligence layer onto the DNO. So you've got the LV network, LV topology flowing from the DNO systems. You've also got the smart meter data flows coming in. Can't read that slide there. Let me just read my notes here. At 5 minutes, and that's 5-minute data at 15-minute intervals. This is where we kind of use the FlexiGrid platform, the ARI, and the Tatari to so the ARI essentially takes the LV, does the LV visibility and analysis. The Tatari takes the digital twin components of it. Both of those components work together with TIA, which is the flexibility component. That's the part that creates the DOEs for us to then interface with our DER aggregators. We are creating some business logic between that particular FlexiGrid platform and the DER aggregators. There is a degree of business intelligence that we need to build that we've identified, like managing the asset registers, etc. And then this data is communicated onto each of the aggregators. And for now, it's an EV charging aggregator, which who then kind of manages the DER asset. So the idea is based on the network, the DSO creates energy orchestration, or the DOEs, unlocks the flex and stretch on the network, calculates that, and then sends the DOEs to the aggregator to then respond with the asset, and that creates the end-to-end orchestration layer between the DNO to the asset. Next slide.
Moonis, sorry to be the timekeeper here, but we probably only have 1 to 2 minutes left, so I have to be strict with that. My apologies.
No worries, no worries. So look, I think I've kind of mentioned the 2 phases that we're in. The first phase was the simulated data set 1, which we've completed to demonstrate that this works. We're now in the phase 2, which is doing this live on the network, and we're building this capability and creating the commercial propositions with the end customer to ensure that whatever we build on a network side actually sticks with the consumer, and the consumer sees end value into it as well. Next slide. Challenges and opportunities we face. Look, building a dedicated DSO environment away from the core to ensure that we're learning safely. Obtaining granular low voltage visibility. The whole DSO game for us is on the low visibility network. So getting 5-minute metering data for us was not easy, and just mesh issues, accuracies, and integrations. The accuracies then impact the way we do forecasting and DOE calculations. Gets us to the point where we need to look at other solutions like transformer monitoring, and a couple of others over there. So performing good customer research was really important for us, and that's something that we continue to do. And the last slide is just something that we shouldn't forget on this journey, which is customer experience is super key, and you need to drive tangible customer outcomes. So got to test, design, test, learn, and iterate. The need for granular low voltage visibility, again, use a multi-model approach. So don't put all your eggs in one basket, which is for us was smart meter basket. Standards-based approach for interfacing with DER aggregators like IEEE 23.5. Security was something that other presenter also mentioned, and building, I guess, the last thing that we have learned is there's no one size fits all. So if there's a model that works for another organization of a different size, it's not necessary that it'll work for us as well. So just got to do our own due diligence to ensure that the consumer value has been extracted and has been delivered with the customer. And that's me. Thank you, Taylor.
Thank you very much, Moonis. And I would now like to introduce Lenart Ribnikar from Elektro Gorjenska. I hope I'm pronouncing that correctly, who will also be joined by Andrej Souvent, the CEO of Operato. So the floor is yours. I'm sorry, I have to be very strict on the time. We are running a little bit over. The floor is yours.
Yeah, hello, and thank you all for being here. So my name is Lenart Ribnikar from Elektro Gorjenska, and together with Andrej, we will represent to you our project Trafoflex. You can go to the next slide. So the first thing is, first I'll talk briefly about Elektro Gorjenska. So we're a small Slovenian DSO company providing electricity to around 90,000 end users. And our grid consists of 13 high voltage to middle voltage primary substations and nearly 1,500 middle voltage to low voltage secondary substations. One of our main focuses in R&D department is the smart asset management, and I think that it is strongly connected to DTR calculations. So if you go on to the next slide. So our project goal for Trafoflex was mainly to develop, test, and validate a dynamic thermal model of transformers, of distribution transformers, that considers different types of substations. and then to develop the concept of advanced use of transformers for power system operation, flexibility market, and asset management, leverage this calculated dynamic thermal rating. So just a quick short description. The dynamic thermal rating is a power system operation concept aiming at maximizing utilization of the equipment. So if the weather conditions allow it, if we have cold weather and wind, this serves as an external coolant for our transformers, and we can load it above the rated power, and this doesn't affect their lifetime. So to proceed to the next slide, please. So we had two main motivations. The first was the peak load growth of the transformers. This is mainly due to the massive transition to electric heating and the increased integration of electric vehicles, charging infrastructure. And this pace of the peak loads growth poses a big problem for us. If we take into account also the massive integration of renewable energy sources, this could be, this pace of the peak load growth can be greater than the ability of the DSOs to reinforce the grid, meaning that we need to it's important to utilize the existing distribution power system infrastructure as much as possible. That is why we implemented the DTR calculation. So proceeding to the next slide. So our concept was to deploy DTR calculations to 19 middle voltage to low voltage secondary substations of different types, meaning pole mounted transformers, standalone transformers, metal enclosed transformers, and substation inside other buildings. And we implemented this on different kinds of transformers in the range from 100 kilovolt amperes to 1000 kilovolt amperes. And on the right side, we can see short representations. So the pictures show all the 4 different types of substations. And we have 2 main inputs to the system. So the first one is weather data, and the second one is operation or meter measurements. We measured the secondary currents. And the result of the calculation was transformers loading limit, loadability, top liquid, and hotspot temperatures. Proceeding to the next slide. And for validation of our calculation, we also implemented an IoT measuring system. So the IoT measuring system was developed and implemented to obtain data, as I said, for thermal model and for the verification of the results. On the left side, you can see a picture with 3 white boxes. Those are temperature sensors that we needed. So one is for hot spot, for cold spot, and from the temperature where the transformer is faced. And then we used the gateway to send the data to Sumo Cloud, where calculations and validations were made. So if we proceed to the next slide. And then also we made data visualization using Grafana. Here you can see 4 graphs, and the most important one is the right one in the bottom, which shows the loadability of transformers. So the blue and the yellow line show the current loadability, which is around 0.5, which means 50% of the rated power. But the red line shows the possibility of the transformer load, which could be even up to 1.7 times of the rated power. This shows promising results for the DTR also in our grid. So next, if we proceed, we'll go a bit more to the technical details, and I'll give the floor to Andrej to present it.
Yes, hello to everyone. So you are probably familiar with the conventional models of transformers, like IC, IEEE, SWIFT, Souvent, and so on. But for this purpose, we construct a general multi-mass model that allows us to simulate heat transfer between n sequential bodies using different mechanisms of heat generation and transfer. Because, of course, we have, let's say, pole-mounted transformers, which are exposed directly to the environment. And then we have, of course, transformers which are inside of the substations, which can be a concrete building or metal enclosure and so on. And besides just the temperature, our model, which was developed in the scope of this project, considers also natural convection, forced convection, radiation, so cooling by radiation, solar radiation, even rain and evaporation. So this is if the transformers are, let's say, exposed to the environment directly. And we, of course, in this project, we used, let's say, 2 bodies model and 3 bodies model. 2 bodies in case of pole mounted and 3 bodies in case of others. And all these models have parameters which must be then learned out of the data. So next slide, please. And these are results, and how the results depends also on the duration of the training data. So we can see the main absolute error in case of this pilot project, where 19 transformer substations was used. So the error is well below 2 degrees for most of the substations, and the stations with higher deviations are usually pole mounted, because we didn't consider all parameters. Rain was not considered during this pilot, and even the wind not. And we can see at the first substation Železno that the error is greater, but this is because the length of the training data was considerably smaller as for the others. And next slide, please.
Andrej, just to say you have a 1 minute left.
No problem.
Okay.
Yeah, and now the results just presented as histograms, so you can see the deviation. The graphs are plus minus 5 degrees. And next slide, please. And this is what we can gain. This is loadability in different seasons, what we measure during the project. You can see that we can utilize the transformers almost up to 2 times per unit regarding to the nominal rating. And usually the winter, of course, is the season where we have the most of the additional loading band available. Next slide, please. So this is how we then use this in persistent operation. We trigger the flexibility activation based on the dynamic limit, not based on the static limit, and that's why we avoid some activations which would be needed if we would be using the static loading limit. Next slide, please. Then the DTL system, of course, is then integrated with other systems. We have integration with flexibility platform. From the MDMS, we are getting the data from the operational measurement. It is then integrated with DMS, SCADA, and with big data platform, mostly for the analytics for the asset management. Next slide, please. Just to conclude, so in the scope of this project, we successfully implemented this multi-mass model. And the accuracy of the model is very good. It is below the 2 degrees sitting rate. And of course, we must be aware that the key uncertainties arise from the weather data. So the results are used both for the operation and also for the asset management. And it brings benefits, of course, in terms of deferring investments and reducing the need for the flexibility activations. So I hope I was in the time frame.
Thank you, both Andrej and Lenart. Thank you very much for this very interesting input. And now we move away from the strict DSO perspective and looking a little bit more from a Brussels regulatory perspective. I would like to introduce Arsim Bytyqi, who is a senior coordinator at the EU DSO entity and who has been working in energy previously with ENSOE and has been working in energy on TSO DSO level for more than 15 years. So Arsim, the floor is yours.
Thank you, Leila. Happy to be here with all of you. It seems quite international webinar. I see also going beyond Europe, so it's very interesting and exciting to be here. Yes, indeed, I will try to be within the minutes and try to be on very high level because I represent EU DSO entity with many DSO members. I will try to stay on that level and represent that kind of view from the entity. Yeah, if you more or less, I will try to focus on knowledge sharing at the DSO level and also tackle some of the challenges that we have. So maybe three main parts. The first is to see the current stage of the knowledge sharing at the DSO level. Then what are the requirements and expectations of the DSOs in terms of how to integrate and to interact with innovative technologies and to solve pressing needs at the DSO level. And finally, I will also reflect a little bit on the research, on the paper, and on the contribution of the current organization on this regard, and then see some common points that we have, and also some of the advantages of that. So the knowledge sharing at the DSO level, I would say, yeah, it's still being structured. I would say in regards to innovative technologies. As we know, the DSO environment is very dynamic, is changing a lot, and not only the DSO environment, but also the surrounding developments and challenges and other sectors are changing rapidly, and they are impacting a lot the DSO community. So in this aspect, we need a lot of knowledge sharing. We need a lot of practices in place. We need a lot of strategies in place. At the moment, I would say that we have 5 key DSO priorities on the high level, where we interact a little bit more with each other within the DSOs, but also DSO, and also DSO and commission and other stakeholders. So the first, the 5 most important, let's say, categories where we work a lot and interact, and where we interact also with technologies and solutions, is on resilience and cybersecurity, smart grid, flexibility and demand response, DSO interaction, data exchange, observability and controllability of the grid, efficient smart infrastructure, and collaborative network planning. So these are the 5 categories where we have a lot of work ongoing. And what I listed, the 3 main parts, is where we have more knowledge sharing also in terms of what technologies are solving what, who is doing what, because these 3 first categories are covered also by network code. So we have a network code being developed where we interact a lot with DSOs, with expert groups, with DSOs, with European Commission and other stakeholders. For example, if we take cybersecurity, we have a lot of activities ongoing on cybersecurity, how we can make cybersecurity, how we can assess certain risks, which technologies are connected there, and how the future technologies should comply with these cybersecurity aspects in network code with the methodologies that we are developing and so on. So in here we have a lot of knowledge sharing between different levels in terms of how the innovative technologies should comply in the future, what are the innovative technologies there, what they are solving, what they are missing, and so on. So on these 3 parts, we have a little bit more. And then on the 2 other, let's say, observability and controllability of the grid, and efficient smart infrastructure and collaborative network planning, I would say maybe a less interaction, because we have a lot of work inside the DSOs, but we don't have a lot of interaction, let's say, with DSOs and with many stakeholders, because it's becoming more specific. So I try to shape on this way, but in general, collaborative approach, engagement with stakeholders and innovations is very essential to meet the DSO future needs. So this is where we are at the moment. Of course, we know that the private sector is having some contribution on the bringing the knowledge about technologies, about new technologies, existing technologies that are updated, standardizations. So we have a lot of information spread around also on private sector, but not consolidated information which fits and which somehow feeds the DSO needs at the moment or at the desired level. So maybe I go on the next slide a little bit more on that. As I said, so we have a number of technologies. We have sometimes in some sites, in some maybe organizations, some high level mention of the solutions and so on, but not very useful, because we have no link to concrete use cases and challenges that we have at the DSO community. And this is very important for us. So we don't need to say that, yeah, we need to use the, let's say, artificial intelligence, or we need to use all the digital twin in general, because that means a lot of things for the DSO, for the power network. So we need to really link to the use cases, to the challenges that we have, to the demands and requirements that we have. And in that case, that is very helpful. In case that we have this kind of information, that is very helpful for the DSOs. It's not all about listing, understanding and creating a group of names which are already available, but connecting with the needs, connecting with the strategy topics, connecting with the requirements is very essential for the DSOs to have this kind of information. So the information should be also compact, should be comprehensive, but we should not, I mean, at least from our perspective, what is useful is not the information that is just spread available there, but information that is very, very going to the details, to the needs of the DSOs. And of course, it's a very big challenge, because we have a lot of contribution from the private sector developing solutions, developing products, sometimes difficult for the DSOs to understand also, because they are also rapidly creating new solutions, trying to meet the needs and the future requirements, which are quite demanding. But then there is the link between understanding the advantages and the let's say the missing elements on these innovations is still also not very well understandable. We have also on the other side the projects where the DSOs, many DSOs participate in the European projects, where new technologies, new solutions are being developed. Let's say new data exchange platforms, a lot of architecture level, a lot of different kind of activities. And from there, we get some knowledge, but they are still on pilot phase. We still see a lot of struggle on the implementation phase, and it's hard to understand what is useful and what is not. So this is existing, I would say, among the existing challenges, that linking and connecting innovative technologies with strategy topics is very essential. So we need also, I would say, not only priorities that we have at the DSO, but we see also priorities at European level. What are the strategies to meet the future energy needs? And then I would say that all technologies, all developments should somehow comply with that, should also consider standardization, harmonization, because these are very key elements that are being into the focus, into the target for the DSOs, for the European Commission. So we need a lot that the new providers, new technologies should really look into these criteria, into these cybersecurity requirements, into this standardization, harmonization criteria, because that is going to be required by the DSOs and by all others. So we need to keep that also in the focus in the future. And finally, I will go in the third slide, simply to reflect on the work that has been done on the paper that is being presented here, and that brought all of us here and engaged us together. So I say that open data in general, whatever is open source data, providing good information is very useful to connect innovation with solutions. And we see that open data from also sharing the data from the DSO side on the challenges, on the needs, on various things is helping also the innovative technologies to comply with that. But sharing information, sharing data through webinars, through papers like this, through recommendations, it's very useful, because that is it's a great need to have that in place, so we can see what recommendations are being defined by certain organizations who are in charge, who engage a lot of stakeholders, and who collect and who somehow consolidate this kind of information. So it's very useful. What is needed more, I would say, let's say, comparing to the paper that we have already from the Koran, what I would say is very important in the future is to extend for more strategic priorities that we have on topics. So I would say that is very valuable to continue on the same way and to increase a little bit more on strategy topics. So I would say for the DSO side, it's very important that recommendations should consider the connection between innovative technologies and topics that we have. So I mentioned some priority topics that we have already, but also from Commission, there is a bunch of other similar things that are in more detail, in more granularity explained, that are very, very important, and connecting so innovations that match with many of them. For me, I think that is a priority, that we need to explain more of them, and we need to focus more on them, and we need to recommend them more to see how they fit in the DSO needs. And one challenge that I faced also when I worked with DSOs, when we collected these similar technologies, for example, NSOE Technopedia, also now in a DSO level, is a TRL level. It's very technical part that maybe not a lot to explain here, but we faced a lot of discussion around that, because some companies try to be very fast and say that our TRL level is to a certain number, which is maybe not the case. So we have to be very, very, very careful here on what solutions the certain TRL of the innovative technologies is working, and be specific on that, and really precise that, because that helps then both sides to understand, and not really to, let's say, go over the expectations and so on. So I put as a technical parameter, but very important, because we have had a lot of discussion around in the last years when it came to the TRL, and we had a lot of let's say objections on that. So more or less on the high level, I try to summarize my points, my view, the DSO view, the DSO needs, and also the advantages of the papers like you already published, and the things that you mentioned there. So I fully agree that this is a good strategy to move forward. And I'm open for any question or comment if there is some time for that. I'm not sure.
Thank you, Arsim. There will be some, we have one more speaker, and then we open the floor for debate. And thank you very much for this feedback. And that also brings us back to the overarching purpose of this workshop. The paper that Mark presented in the beginning is where we presented some of the case studies, that we presented some of the technologies that were presented today. Our goal is for this to become a regularly updated document. So we really are looking to you, the community, for feedback and how we can make this more useful. So I very much appreciate this feedback on the paper. We have one more speaker for today, which is Oliver Franz, Chair of Distribution and Market Facilitation at Eurelectric, and also with E.ON, where he is the Vice President of Associations, or if I saw correctly on LinkedIn, a new title very recently, which you will have to help me with, Oliver.
It's European regulation right now.
For European regulation, so congratulations on that. So last but not least, the floor is yours.
Thank you. You will see that I'll be speaking in my Eurelectric capacity, but on E.ON slides, and the reason for that is that it was much easier to present a bit the strategy of the company than for the whole of whatever 27 plus DSOs nationwide, or the 8,000 that we are. And second of all, you might be aware that the big yearly Eurelectric conference, the Power Summit, is coming up, and the Secretariat is actually quite busy in preparing for that. So I basically stepped in for them. So if you go to the next one, please, what I want to do with you today is give a bit of information about E.ON, a bit about the technical vision, and then have some very concrete feedback on the paper, as Lila asked me to have. And by the way, thank you, Lila and team, for having me today, and to be able to present maybe yet another dimension of the DSO perspective on this. So if we go to the next one, what this chart should tell you is that we are in a lot of European countries as a DSO, and that of course creates quite a few supply tasks and differences within the company. So while the Swedish colleagues, for instance, are more or less done with the electrification, if we don't look at the traffic and mobility question, for instance, we have a major decarbonization issue in heat in Germany, for instance. The situation is yet again different in Romania. And the Turkish, of course, just had a catastrophe, which enables us to rebuild. So it is really different. And so our perspective is really a very European one. Usually, if you excuse me, for the joke, we are a bit of a Eurelectric in ourselves sometimes. And that is also creating a bit of a tension field between standardization, which of course is something that we want, and bringing a technology that has worked one place to other places, and of course the individuality that you find in all these countries. Next slide, please. One thing that I wanted to mention on this one is, we're actually spending about 20% of our CapEx now in digitization. And I will try to explain why, because we believe we need to have observability, and that is my key word here. We need to have observability at least on the secondary substation level. And then we believe that by bringing in about 30% smart meters, we will already be able to actually observe the low voltage grid in full, thereby being able to introduce automation, increasing the reliability, create efficiencies that we might not see otherwise, create transparency, and provide much more capacity to integrate green energy. But it all starts by being able to observe. And I believe this is very important because the DSOs are going through the transition at different paces, while some of them are already able to observe a lot of things and might rather be looking at more ways to work that data. Others are really at the stage where they are working to be in a situation where they can observe. And maybe if you would kindly go to the next one. So what we are aiming for is really, by doing that, to have a state estimation in the end of all our secondary substations and the low voltage systems behind that, because we believe that with all the room cooling, heat pumps, battery storage, all that, we will need to be able to have more control. There's also, you might know that, the famous 14A in Germany, which is depicted here on the right-hand side. So we have to have control over certain assets that are around 4.2 kilowatts, or that usually will still be able to get 4.2 kilowatts from the grid. Of course, we will try to get a better detection of congestions. And maybe if you allow me another remark that more or less reflects on a research project that I was involved in already 10 years ago. At least if you look at solar, usually the first thing that goes wrong is voltage. And then you probably have different ways to react than if we now look also at heat pumps or cars, where maybe actually the first thing to go wrong is a thermal issue. And so depending on where you are, depending on how it goes, you will probably need different strategies. And they're all in our toolboxes already now. And that maybe is a difference in E.ON towards maybe the average. We have really moved some of these technologies into the planners' toolboxes so that they are using them. And that is really the step that you probably ought to make. So then maybe this is the last one on E.ON and what we are doing on technology level as a feedback now to the paper. And thank you very much for taking the effort. I'm actually unsure whether we agree to the sentence that says one of the greatest challenges to introducing these new technologies is the time of limited DSO expert resources and so on. I believe other challenges are bigger, and maybe I'll elaborate on that. You seem to be putting a lot of hope on CBAs, which I can understand, and is undoubtedly, especially if you go for net present values, a tool to find out which technology is better for you. But there seems to be the idea that we discuss these CBA results also with regulators. Maybe I misunderstood you, but that's the way I read it a bit. There's this threat. And quite frankly, NRAs do not steer technology, and they're really not supposed to do so. Benchmarks and other efficiency considerations are doing that job. So I believe it's important to recognize that we are the entrepreneur and the regulator is the regulator, and we have two different jobs to do. That creates advantages and disadvantages, but most regulators that I'm aware of are actually quite happy that they don't have to steer technology, because it would create a different kind of playing field. I would like to make one remark on anticipatory investments. It is mentioned in some places of your study. We believe, and we can show that also from Eurelectric Grids for Speed study, which we will reveal next week in Athens, that they are clearly beneficial. So oversizing strategically maybe going to create some context maybe to the first presentation that we saw today, maybe going for high temperature, low sec immediately, even on a new line, though it might be more costly, is probably what you want to be doing. But the NRAs still need convincing, and maybe that's also a topic for cooperation here between current and Eurelectric and the DSO organizations more in general. Again, I'm not sure whether I misunderstood you, but the way I read, or we read, your remarks on national tender regulations, I don't think that though I understand its intention, that it's gonna work like that, because actually what especially our CEE colleagues tell me is that they have to be very, very specific in the tender regulation, describing what they want and what they need, because otherwise the tendering authority says, no, it's not specific enough, and you're just trying to sneak something by me that I don't want to have. And by the way, for an international unit like ours, the fact that we have to run one tender in Romania, one tender in Slovakia, and one tender in Czechia, while we might actually be able, especially between Slovakia and Czechia, having this common history, to create some synergies by doing one, is also an obstacle. You also had a few remarks on monopoly regulation. And I just wanted to point out that from my personal experience and also what I see in a lot of the association work that I'm doing, the trouble sometimes is not regulation, it is accounting. Because in quite a few member states, you are not allowed to activate ICT spending, which means that it's OPEX only and not CAPEX. And there is always this issue, of course, but sometimes the problem really is on the accounting rules. And maybe that's another issue that at least we can communicate about together. And then if you would kindly go to the last and next one, and thank you for the feedback. More generally speaking about natural monopoly regulation, I believe it's a bit more complex problem than described in the paper. Ricardo was mentioning it earlier as well, speaking about OPEX and CAPEX. The way I would say it is that what we need to do first and foremost is we need to overcome the disincentive for OPEX, because OPEX are still in most systems under budgets. They are capped if you want. So if I increase OPEX while I go in a regulatory period, I more or less have to find any kind of efficiency to finance that, because otherwise I'm actually left, at least for a time, with less EBITDA than otherwise, and I'm not able to recoup that EBITDA later. Another point that I wanted to make also with regards to what we saw in terms of high temperature low sec, but some of the other technologies, many of these technologies will increase losses in the system because we are running the system towards its technical limits, and rightfully so, because we want to increase capacity. But that's an issue that we need to tackle in regulation as well, because the least thing it necessitates is a very open-minded thinking about whether the rather traditional loss reduction targets that we have given to some of these DSOs are still justified, or whether we need to look at, let's say, a more moderate way of doing that. And one of the things that I believe also we should be cooperating upon is actually existing right-of-way corridors. I believe also this was very present in many of the other presentations. Having said that, we already have an issue, to my understanding, in Germany, when we actually take off one overhead line and put another one in, because it might need us to necessitate a change in the permit. Why you might say, yeah, why is that necessary? Because some different electrical and electromagnetical interference happens. But you might hopefully be able to say, if we're operating in an existing right-of-way corridor, and maybe by however you do this in a legally possible way, but we need to be able to say, okay, certain changes in an existing right-of-way corridor can be done without permitting, because that will increase speed. And then finally, and the colleague from the entity has been talking about this, of course, the Technopedia, this is done, that is work done that is supposed to be done by the entity. There is a project concept under development, and it will be shared with the advisory group shortly. Current is participating in that. Thank you. Very much welcome to do that. And one more thing, that I would like to mention. There's another Eurelectric study out in a week, which is called Wired for Tomorrow, and that looks at digitization only, so much smaller than what we discussed today. But what that shows is that in terms of digitization, there is no single DSO leader in Europe. But the bigger DSOs and the smaller ones sometimes are very specialized in certain technologies because they're, in terms of digitization, because the development of these have been driven by their supply tasks, if you want. So cross-learning, even between, let's say, the likes of Enedis, E-Distribuzione, E-Redish, and us, is possible and fruitful. So we really need to do that. And I would like to close with a quote from our board member responsible for E.ON Digital, which is Dr. Victoria Osadnik. We love technology, and it's very true for E.ON. We believe that technology is a major lever to get this problem done and fixed. And this is our mission. Get it done and fixed. Thanks.
Well, I think that is, thank you, Oliver. That is a mission that we can all get behind. And at current, I think I can speak for all members that we also certainly love technology. So thank you for that. I now open the floor to questions. I just wanted to give maybe if Mark Norton wanted to respond to some of the feedback on the paper while we give people a chance to raise their hand. Otherwise, I also certainly have questions for some of the panelists. But Mark, I can't imagine that you don't have some comments to this.
Thanks, Leila. I'll try to be very short, just to give other people an opportunity to speak, of course. First of all, thanks. That's exactly what we're here for today, is to get feedback and to understand what we did right, what we did wrong, what's missing, the gaps we need to fill on the paper. So I'm very welcome for the feedback we've already received from the people who have talked, particularly Arsim and Oliver. Some of the things that are there, clearly we need to maybe clarify what we're talking about. I think things like cost-benefit analysis were mentioned. I think it's a question of looking at an equitable comparison. We realize that depending on your structures, you could end up having to be more actively or less actively involved with regulators in regards to that. But regardless, there will be an approach to select different technologies and the choice between them. So trying to get that methodology equitable to look at the different things and to include all the right factors is important. Tenders is a really thorny issue, anything to do with the legality side of things, but I suppose we'll go back and revisit that one, absolutely. But really the call is for things that are functional. So rather than saying I want a transformer, a line, or a circuit breaker, whatever it may be, it's more a question that I need something that can make this amount of change on my network and will comply within these constraints, whether it be voltage or frequency, or whether it be communication or controls, and to leave that more open to look at technological solutions to meeting that. I won't go through all the rest, but they're probably the big ones that jumped up. The only one I will say is rights of way and trying to deal within the planning arena. Having now dealt in probably 20 or 30 different countries across Europe, they're all different. They're all difficult. They all take a different approach. They're all supposed to be under an umbrella of the same European legislation, but it's amazing how many different ways you can choose to apply that as a consequence. And I totally agree. In some cases, you can take things down and change them over quite easily. In others, it's very rigid on what you can do. I think there is a huge area which would help, whether it be lines, corridors, cables, or stations, improvement. And I think a general call, the whole industry should get behind that. We don't want unnecessary bureaucracy or difficulty in actually implementing projects. It's challenging enough as it is, respecting the legislation we're looking for. I'm going to stop there because I could say a lot more, but I don't want to take it all over and not allow the floor to speak. So thanks, Leila.
Leila, if you allow me to, may I react to one thing that Mark has just said?
Yes, of course. Please. And in the meantime, to the audience, if you have a question, please raise your hand using the function, and then I will enable your microphone. So please go ahead, Oliver.
So like I said, as an economist, I couldn't agree less with doing the CBA. But I also believe that, of course, depending on the size of the project, it's probably sometimes you have to accept that the CBA has to be taken into more to a rule of thumbish kind of thing, because the planner needs to work it. So
Yes.
you have to tell the planner, usually in this case, try this technology first, and then maybe go to that one, and then a third one. If it all doesn't fix your problem, then go to just expansion, if I may say so, because otherwise the poor planners will not get their job done either. So it's we need to be very open, and we need to agree, let's say, also maybe on timeframes to when to look for, how fast or not fast those benefits should realize. But the planners really need to be able to do their job. So either we give them a lot of artificial intelligence, or we need a bit more a shortcut sometimes, maybe.
Yeah. Having been a planner for 30 years before joining Smart Wires in both distribution and transmission, I wholeheartedly agree. It's a hell of a challenge when you've got a plethora of different solutions to be applied, and you definitely have to use rules of thumb. So we share that one, absolutely.
So maybe some questions to our earlier panelists that we had specifically on the DSO side. What would your number one advice be for other DSOs for adding new technologies to their toolbox? And what kind of information is most helpful to also sell these technologies internally? So this is a question to all panelists. If someone wants to go first, go ahead. Otherwise, I will call on you, Andrew, please.
So I can answer that. So for me, it's really typically it's not the business unit that deals with this on a day-to-day basis that would do the implementation, especially if it's a new technology. So I sit within the innovation team. So it's that early interaction with the businesses that interact with this on an ongoing basis. So bringing in a collaborative approach to deploying this on the net on the network. So it's really ensuring that you've got your full key stakeholders on board at the very beginning. So it is, we say CBA, I think a CBA for that deploying that on the network is key to get the stakeholders on board of why you're doing this and what the benefit is going forward. So it's bringing those in at a very early stage.
Yeah, so the CBA, not necessarily for the regulator, but to bring it internally, to sell it to your colleagues that are doing the actual implementing, if I understood correctly. Yeah, very interesting. From our other panelists, either Lenart or Pat, would you like to respond to this? Yeah, Pat, please go ahead.
One of the things, the planning thing that Mark pointed out, I absolutely agree. From someone who's used to delivering projects, it's torture waiting to try and actually get started, which seems to just, the timeline keeps moving to the right continuously. This need to consult continuously and having real difficulty in tying down a design. One of the things for innovation, I would say, I talked about it briefly, and I'm sure Andrew went through the same pains, is getting something approved, whether internally or externally against a set of standards. Also, you don't know whether another company has actually done all the same testing. If there was some way that testing could be shared, even if it stayed with the manufacturer, it would mean a lot of innovations could actually be brought in much quicker. You know, we went through months and months of testing to prove internally and externally that this HTLS was going to be okay and was going to be fit for purpose. They've used it elsewhere all over Europe, right? So transmission. So, you know, but there was an insistence on our company doing its own testing. Now, if there could be a much sort of more, I'm going to be blunt, grown up way of sharing that information, I'm just being honest, right? You know, if we could have a lot more trust, perhaps is a better way of putting it, in an independent set of results, then if you identify a product that you want to try, like Andrew's bits of kit there, then another DSO could effectively almost take that off the shelf, right? Now, there needs to be some way of recompensing Andrew for having done all the donkey work and getting everything tested and verified. Otherwise, no one's going to be the first to use it. You get my drift? But it would allow everybody to move much faster into implementing the use of that new technology. So that's where I think it will be a sort of a good starting point.
And pardon my ignorance, but what would you say is the reason that this testing is not being shared? Is there a confidentiality issues with this, or is it an organizational challenge?
I think it's commercial. I'm just being honest. I think, you know, a lot of the regulator likes to, certainly in the UK, likes to play the DNOs off against each other, who's more competitive than somebody else, who's outperforming somebody else, and so it's not wanting to give up competitive advantage, I would say. You know, if you aren't in a private environment, then there can be a lot more sharing of information. Certainly pre-privatization, and yes, I have been around that long. There was a lot of collaboration. In fact, there was a magazine that used to go about where people used to write articles in and actually show off what they'd tried. You know, back to the days of sort of directional drilling for cables, which was an innovation. And there was a lot about that, and it was great because you actually you had contact details for a person. You could pick up the phone and speak to them about it. But it's not so open now.
Yeah. Okay, that's an interesting obstacle. I imagine Oliver wants to respond. I also Moonis, I know it's getting late where you now are, but if you or Lenart also wants to respond, you're welcome. But first, Oliver, please go ahead.
Thank you, Lada. So I just wanted to mention two things that I've been observing, especially since E.ON came together, and you might know that it is basically two large DSO organizations that have been merged. I believe management commitment is a strong thing. I mentioned the quote by our Chief Technology Officer, and that chant, if you want, is also repeated by the CEO, by our CEO for the grids operation. If Thomas goes someplace and he's being told, we did this with traditional technology only, he will frown and say, yeah, but why? Wasn't there any other option? Usually it's faster, it's maybe even cheaper, and so on. So that's one thing. And also, to be honest, before the meter as well as behind the meter, so in the grid business as well as in the sales business, we have actually been integrating some of the technology vendors that we use, or partly integrating them, because trust was mentioned just right now. That was rather intercompany trust, maybe, but yeah, so I believe that also that integration in some parts, I'm talking about in Velio, for instance, created an atmosphere where now it's clear, okay, this is the technology we want to use, and therefore we go into the rollout.
Yeah. No, I think also trust, and that's definitely something with the paper, to also, trust within the company, of course, but then also, sharing the experiences with the technologies, is important. Arsim, please.
Yeah, if somebody is before me, so feel free to, because I just
no, go ahead.
My hand. Okay.
Yeah.
So I just wanted to say another thing, maybe connected to that, but from another perspective. What I see important also for the whole community is understand the requirements. So how do we understand the DSO requirements? Today there is not much open information to know what are their technical or scientific or whatever requirements to be filled by the others, by innovations. So there is not much open data, there is not much platforms that also we understand, and then the private sector or whoever will react with developments, with solutions. So I think open innovation is one good place that companies are interacting, but I don't see a lot of energy community interacting with that, and I see a lot of let's say I see advantages of that. So probably it's something that also from the DSO side we need more requirements to be opened, and then the match will be much easier, because for the moment, due to many things, maybe companies stay very isolated. And then I think that will prevent the solutions to come faster in the place. So I think on that perspective, there is a need to have some progress as well.
Yeah, thanks, Arsim. Maybe just some comment from the chat. There was one comment that HTLS does not increase the losses, but I think Oliver was referring to different technology, not specifically to HTLS, but I didn't want it to go unnoticed, this comment.
Indeed, I was also wanting to apologize. I was not trying to put the blame on any specific thing. Very sorry.
No, of course. And then we also have a question from Ricardo Vailati, who is with ARERA, the Italian regulator, who asked if we can share more insight on quantification and monetization of benefits of distribution network developments through innovative solutions. I think we need a separate webinar for that, but I think that it's definitely something, unless anyone wants to speak to that in a few minutes, but that is definitely something we can try to include in future editions of the paper. Mark, did you want to say something on that now? I also have one more question from Sebastian before, probably that will be the last question.
I was just going to say, as the chair of the DSO working group, that yes, you're right, we need another session on it, but I think you've already said we will definitely commit to do that. So we can, as a response now, we'll say we will do it. We'll work at the best way of doing it, and maybe directly in the paper, and maybe an addendum to the paper, but we'll work on that. And thanks for that suggestion.
Yeah, sometimes for us it's very obvious the benefit. So good that you tell us that. Sebastian, have you lowered your hand? Do you still want to ask a question?
Well, actually, hello everyone first.
Hello.
It was less a question than for thanking you for the webinar, and also a reaction to what Arsim said lastly about the isolation of the different DSOs, and the issue about open innovation. So definitely with the organization I'm representing, so CRESIM, we are for open innovation, and if any of you here have proposals to develop cooperation in this respect, I'd be happy. So we have some proposal if you're interested, so we can discuss it. But I had maybe some bilateral talks to have with one another to check why we have such a siloting in the business, and how we could propose some kind of platforms to ease the benchmark of technical solutions and ease their the bridge between the research and actual implementation. So it was more a comment than anything, but maybe I'm too excited to be able to develop right now.
Well, Sebastian, your enthusiasm is always appreciated. We are very interested also in following the work of CRESIM. So we have a few minutes left. Is there any panelists that would like to say something that didn't yet get the chance to say it? Any concluding remarks from anyone? I see that is not the case. So I would like to give the floor to Mark for the takeaway from today's webinar or workshop, and the next steps for the current DSO working group. And of course, we're always happy to exchange with anyone who is interested, and a future discussion on the benefits is definitely in the cards. So thanks to Ricardo for that. Mark? Thanks,
Leila. You may have seen I was furiously writing as we were going along. I have a lot of notes I'm going to try and distill down into a very short space of time. So if I miss anybody or anything, please, my apologies. I mean, the first thing I'm going to do, which you probably do at the end, but just to make sure I don't miss it, I'd like to, thank and congratulate the speakers today. I think we're very clear and concise, and we really appreciate their time and effort. And everybody who actually joined the call and attended and made their contributions, hopefully loud and clear to us. We are definitely listening to those, and hopefully you'll see through our actions response accordingly. We'll make the deck available and the materials of some of the questions that we actually saw coming through. So anything that you don't see and you would like further information on, please reach out. And I can also extend that as well. All the members of Current, the various different OEMs and people on the call today, or even behind the scenes, have shared their commitment to collaborate with anybody. So we heard from, I think Andrew was the last one to mention it, about the need for collaboration between the manufacturers and the people in the know on the supply side, shall we say, to work with those people in the distribution, system operation and regulatory side. We commit to do that. I think if I try and summarize what we've learned for the paper today, and there's been a huge amount, so I'm going to miss stuff, I'm afraid. But first, we heard that there's definitely a call to share knowledge. So hopefully we're in the right space. There's a lot of use cases that are missing and links to that, to technology that can apply those use cases, and the strategic priorities of actually developing those. All of those, I think, are very clear and simple things for us to actually look at in the paper and to make a development on. We'll look at whether we can do that earlier rather than later, but at the best, I will commit to do that in the second round of the paper at the end of the year, or full round of the paper at the end of the year. We also heard, that there is more work for us to clear up what we're actually asking for, and to be responsive on things like cost-benefit analysis, tenders, the claims that we're making in regards to things like losses and some of the characteristics. Maybe they need a little bit more explanation or in what context they're in. That's fine. It's great stuff for us to have. We can go back to that. We recognize that the Technopedia recommendation that we actually had is a little bit out of date. We were going to update that anyway, but it's like anything else, you do it at a point in time. Unfortunately, things move. We also heard from the European Commission, and talking about, Ricardo was mentioning things like the need to, the necessity of using innovation, and the importance of the report in operationalization, operating these innovations, and how do we actually move that into operational use. I think that's an important thing for us to dwell on how we can improve in that area. But I also was interested, and I would ask a specific question, not to be answered now, but maybe people can write to us on if there are other technologies that you would like to have seen us to bring in that we've missed. And finally, I would just turn around and say that we don't, like the paper, this is a live process. So once we're finished today, please, any comments, questions, queries, one-to-one discussions, anything else that you would like after it, just reach out and we'll try and facilitate and accommodate that. And I can see him at 11 o'clock, so I'm going to stop and just say thank you all. Wish you well, and hope you have a good day, and we shall speak to each other very, very soon.
Thank you. Thank you, Mark, and thanks to all our speakers. I'd like to close the meeting. Just a reminder for those asking, the recording will be available, maybe not today, but in the coming days. So thank you. Thank you, everyone, and have a nice day.
Thank you all. Bye-bye.
Thank you. Bye-bye.